Thank you. So talking about last and second to last, I do realize that I'm the second to last presenter, and I've got to tell you a little story about that. There was this conference I was speaking at some previous time, and I was the second to last speaker, and it's the end of the conference, and it's the second day, just like it is here. And towards the end of the conference, more and more people are leaving. And at the end of it, I'm left with one person who is, very graciously sitting through my presentation. And at the end of it, I go up to him and tell him, well, you really had no reason to sit here because there's nobody else that you're going to be presenting to. And then he tells me, well, I'm the presenter after you. So, I'm glad to see such a big turnout here. I appreciate your tenacity in sitting through this, and we'll try to keep this short. So my name is Shankar Rao, and I work at Quest. I've been there for a few years. I work there in their engineering team, and I'm here today along with Scott Poretsky. Scott and I have been collaborating on some work at the benchmarking methodology working group in the IETF that is concerned with stress testing core routers. So we'll just walk you through briefly with what we're trying to do, and I'm hoping we can get some feedback and some ideas from this operator community here about what is right for us to kind of include in this work item as well. So before we jump into the presentation, here is an agenda. I'll quickly give you a brief background about the IETF benchmarking methodology working group, and we'll talk about the accelerated stress testing item that the working group is currently working on. We'll talk a little bit about terminology and the framework of what we're trying to do. And Scott's going to talk about the methodology, and we're going to conclude with summary and recommendations. So the benchmarking methodology working group, this falls under the operations area. So it does concern folks in this room. There is some operational impact of some of the work that's done there, and most of the work that is done there relates to making recommendations about measuring performance characteristics of equipment, networking equipment. The benchmarking work is usually related to devices in the network, so we're not doing any end-to-end kind of things there. And that's a link for the working group charter, so if anybody's interested, you can look that up. So the stress test work item that the working group is currently considering, there are a couple of those work items that are in there, and this work item is basically concerned with providing the framework terminology, guidelines, and a methodology for providers and equipment vendors to perform stress testing. So this is something that is a collaborative effort. We hope to get more input from the community and kind of standardize how we can test for routers before we actually deploy them in the network. So before we actually jump into the presentation, I just want to define some terms. I'm sure all of you have heard this before, but just to get us on, for the sake of the continuity in the presentation, DUT, device under test. So this is basically the device that is being evaluated. White box versus black box. So most of the testing that we do in that we look at in the benchmarking group is concerned with black box testing. So we want to look at external manifestations of problems. We don't necessarily look at what's happening in the router in terms of memory and CPU utilization, although as operators, I'm sure we're all interested in understanding the impact there as well. Stress testing. So stress testing is basically this concept of, we'll dig into it in a little more detail, but the idea here is to evaluate router behavior under stress. So this isn't basically just testing for functionality and saying, does the router conform to a particular protocol, but how does it behave under stress when there are multiple protocols running on the particular router. Instability conditions, I'm sure you're all familiar with what that means. Real networks do have instability conditions in them, whether these are links flapping or interfaces going down or routing protocols converging due to other events in the network. And for the purpose of the framework and the model of how we propose the stress testing work item, we basically divided the inputs to the DUT, so to speak, into data control, security, and management plane. So data plane, you're all very familiar with this terminology, and what we do is we define what are called configuration sets. So a configuration set basically defines how the data plane needs to be, stressed, how the control plane needs to be stressed. For example, in the control plane, many of you may be running multiple routing protocols such as BGP and ISIs and LDP and RSVP and anything else that you need to run your particular network. So that particular configuration set will define a starting condition, so to speak, for a particular benchmark or for a benchmarking test. And then the evaluation benchmarks, how do we exactly measure pass and fail, again based on from a specification standpoint, black box behavior, but also from an operation standpoint, what is the box actually doing? So why is stress testing important? Now, I'm sure, we're all smarter than this, but a lot of testing that we typically see is testing of that is done of functionality, kind of independently. So you've got a BGP testing running there, and then you say, my BGP routing protocol scales to 300,000, unique routes and X million paths, and so many number of sessions. But then, and then we do the same thing for different kind of protocols, such as LDP or OSPF or ISIs or whatever you may be running. But then the reality is a router that is running in your network is running probably multiple of these protocols at the same time. And at least in our network, that has been the case where we previously used to just have BGP and ISIs. We're running RSVP and LDP and various other things that we might want to, either at the core or the edge. So the isolated testing is a great way to test functionality. It's a great way to test, to see if the router conforms to a particular specification. But however, it really doesn't tell you how the router might perform when you have multiple routing protocols that are actually stressing the box in an operational environment. And also remember that there are instability conditions in your network. So it's not just these routing protocols come up and everybody's happy. That there are things that occur in the network which might cause convergence events and potential failures. So so basically the idea here is by deploying or by using this particular methodology to stress test routers before you deploy them into your network, you should have a better sense for how the particular device will perform in your network that may be unique in terms of the protocols you're running and in terms of its scale, and also in terms of the instability conditions that you might be seeing in your network. So we just talked about this. This basically presents more of a functionality testing view of how we might test a particular router or switch, but not necessarily stress testing it. So this slide basically presents a stress test model. So what we have here is we've got the router or the switch, which is the device under test, and we've got all these different modules, the management, security, data, and control plane modules that are kind of pre-configured to a particular threshold that might reflect what your network might be running at under normal conditions. And then what we do is we introduce these instability conditions. Okay, so those instability conditions might include things like BGP routes flapping, IGP routes flapping, LSP reroutes occurring for various reasons, and and actually the data plane going down itself. So each of those planes may have a particular configuration set that is defined, like I said earlier. So the data plane might have you've got X number of line cards of certain type, and they're running at a certain speed, so that the router is actually stressed a little bit on the data plane. On the security plane, you may have ACLs and things like that that are also defined. And on the control plane, you may have multiple routing protocols again, each of those running at different levels of scale. And what is also very important, of course, is that when these routers are doing all these things that they're supposed to do, which is route packets, you're also able to manage it. So you should be able to, for example, initiate SSH sessions and do your SNMP logging and anything else that you might want to do to make sure that you bill your customers or manage the network. So some of these stress test measurements, what do they help us identify? One thing that we believe it will help us more quickly identify would be memory leaks. A lot of times what happens is with some of these slow memory leaks, when we have constant route withdrawals and updates and things like that, you may not immediately see a memory leak, but over a period of time, if you keep doing this, and we've all seen this in different router implementations, over a period of time, you see your memory getting used up and basically causing problems on your router. So by stress testing your router, it'll be easier for you to detect some of these slow memory leaks. And also the impact on the stress testing for CPU utilization. The other thing there about CPU utilization is, we all know DOS attacks occur, and usually DOS attacks are targeted towards, if they're targets towards the infrastructure, they're targeted towards the resources on your router. So you want to be able to understand what the impact is on the resources, whether it's memory or CPU, under different conditions. So I think that'll help you benchmark that kind of an environment as well as multi-protocol coding logic. So if you have a router that's just running BGP and ISIs, everything may be doing, it may be perfectly happy and doing everything well. But if you introduce some other routing protocols and then have the router kind of operate under stress, we're not quite sure that it'll operate as defined. So we believe that there may be some opportunity for us to uncover some multi-protocol coding logic when you're running multiple protocols. Also to verify manageability, to be able to ensure that you can manage these devices when, for example, you are maybe under a DOS attack of some sort and your router is under, is running out of resources. You need to be able to make sure that you can manage those routers still. And the other thing is also to evaluate convergence under stress. So, network failures occur, there are links that go down, there are routers that go down, and we've heard all these talks about how we can make these convergence event occur faster. But what happens if your router is really operating under with limited set of resources, with limited set of memory and limited amount of CPU cycles? So do you see the same kind of convergence occurring then, or is it different? So some of the benchmarks that the stress testing might use would be, these are, the first two are what we defined earlier as being white box measurements. So you might be interested as an operator to understand what the CPU utilization is. So again, this gives you the opportunity to kind of benchmark your router and say, I need to be concerned about my CPU cycles running out if I turn on, or if I have these many number of BGP routes flapping at this rate or something like that. And also memory, we defined earlier that some of these slow memory leaks that occur over a period of time, we want to be able to accelerate conditions to hopefully bring them out earlier. And the benchmarks at the bottom are basically what we defined as a black box or observations there, where we define for each of those control planes for the threshold of time that you define for your test. Do you observe any errors, whether in the control plane where a BGP session might drop, or in the data plane where your packets might not be getting forwarded correctly, or in the management plane where you may not be able to SNMP pull the box or initiate an SSH session to it, or whether your ACLs are performing as advertised. So those are all benchmarks that we can kind of measure the box against. So in the following slides, Scott's going to talk a little bit about the methodology of how this testing actually is done, and also wrap up for us.
Thanks, Shankar. I am Scott Paretsky of Corey Technologies. Shankar has talked to us about the importance of stress testing, how by doing stress testing and making subsequent fixes in routing devices, we create more stable routers, we create more stable protocols. We also create routers that are more survivable to attempts at resource exhaustion with DOS attacks. And the other thing is, of course, manageability under stress. Are these routers manageable under stress? Shankar has also talked to us about the stress testing model. It's a big test. We admit it. There's a lot going on here. So to simplify it, we created separate blocks in the model where you have your control plane, management plane, security plane, and data plane. You break those down separately. You can create your configuration sets, your instability conditions, and your failure conditions for each of those planes. So modeling it like that simplifies the test. You do have failure when this test is running, when you have a session loss in the control plane. So it's important to point out that the failures are observable externally from the device, referred to as a black box observation. So externally, we can observe control plane failure via a session loss. On the data plane, we can see misrouted, lost, or reordered packets. On the management plane, we can see denial of access to the box. Can we no longer get into the box under stressful conditions to actually manage it? Or do we see something as simple as value errors returned via SNMP or in statistics on the box? Those need to be correct as well under stress. And then the last, on the security plane, are the filters or the ACLs still working correctly under stress? We need to make sure under stress a networking device does not incorrectly permit or deny certain traffic. You know you pass when you have a certain threshold of time that you set, that these stress conditions, these instability conditions repeat itself. If you can go so many hours that you predetermine what's best for your network, then you have a pass. Okay, it's probably pretty good here to look at an example where you can see we have separated configuration sets for the data plane, security plane, control plane, and down in the bottom left-hand corner, the management plane. And then over in the red, in the bottom right-hand corner, are the instability conditions. The specific values and parameters will vary with your network and your requirements. What's important to note here is that you can do multiple iterations of this test to characterize the device under test. So you can pick your certain values and monitor your CPU utilization, memory utilization, and look for those failures. If you have a pass or a failure, then you can tweak the numbers, create new configuration sets, and then do new iterations of the test. Multiple iterations gives you that full characterization. So what will you see while the stress test is running? Well, with all these instability conditions we're doing, and just in review, we'll look down there. There's route flaps on BGP, IGP, MPLS reroutes. You can do cycling of interface shutdowns. You can have links with more than 100% utilization. So with all this going on, what you're going to see on the box is a lot of route convergence events. There is a lot of flapping. So you get route convergence on BGP. You'll get route convergence on IGP. And of course, you have BGP next hops dependent upon IGP. And you have LDP dependent upon IGP. So you're going to see FEC convergence. You're going to see BGP convergence and also IGP convergence. This is important to look for in a stress test because these kinds of flaps are a common cause of slow memory leaks. The kind of memory leaks where with each flap you'll lose 4 bytes and you won't notice it until 6 months after a software is deployed and your box crashes. Well, with this accelerated stress testing, you can find this in hours instead of weeks or months. Okay, the next thing is you're going to see nested convergence events. There's a lot happening at the same time. You're already flapping BGP when you're doing a shutdown on an interface, which may have an eBGP pair where you're learning your BGP table. You're going to end up with what we call the nested convergence events. While you're converging, you're going to have another convergence event. This causes high CPU utilization on the networking device as well. You can observe the behavior of the device by doing this test. And then another piece is fast reroute failovers may also happen while you're converging. Again, a cause of high CPU utilization. Then, besides the high CPU utilization and memory utilization, you also need to make sure your convergence completes and you're selecting the correct next hop. There's always a second best next hop for your convergence. Well, you need to make sure you're picking the second best one and not the third best one or the fourth best one under stress conditions. And then the last piece, which is important for management, is to ensure that you can actually enable and use logging and debug on the device under stress. Okay, so like I said, there is a lot going on here. There are specific test tool requirements to do all of this. The first one is you need to emulate multiple protocols simultaneously on the same interface. It's very likely on the same interface you're going to have BGP, ISIS, LDP, and maybe even MPLS-TE. So your test device needs to be able to support that. You need to be able to send and measure traffic in which the destination addresses of that traffic matches the emulated routes and LSPs that you've advertised. You also need to be able to perform SNMP. You need to do your gets, and you need to be able to do value checking on those gets. And then the fourth one is the instability conditions. You need your test equipment to actually go and initiate repeatable route, session, and link flaps. Okay? So from a system level on your test equipment, you need protocol emulation on a variety of different interfaces, being PAWS, ATM, frame relay, gigabit Ethernet. You also need high port density on those because you're going to use a lot of interfaces on your device, like you will when you deploy this box. You're going to hopefully use a lot of the interfaces on the box. And that means that this test device needs to work under stress. The stress testing is only successful if the test device itself can work under stress, and it will be stressed. Okay, so if those are the requirements, what do we have for limitations in commercial test equipment? There are a few. For various vendors it may differ as to which one it is, but I can guarantee you now no one will support 3 out of the 5 will support more than 4 out of 5 or 5 out of 5 of that list of common limitations. Because of that, there is the need for test engineers in the lab to actually build their own tools to go do this, or use freeware, like a freeware tool that does SNMP MIBWalks, for example. So let's go through these. Establishing multiple protocols on the same interface. Direct traffic to emulated routes and LSPs. Induce instability conditions at repeatable, configurable rates. Perform SNMP, MIBWalk, and value validation. I can tell you right now that none of the IP test equipment vendors does SNMP, none. So you automatically, right off the bat there, need another tool. That's bad for us, the people who need to run this test, because it complicates the automation of these tests. If all of the functionality for these tests, all these features exist on the same test device, then it's much easier to automate if they're all on different test devices or running on different Linux PCs. That really complicates the automation. So that's something we really need. Okay, and then also it needs to be stable when actually introducing the instability conditions and running multiple protocols for continuous hours. Okay, so we have summary and recommendations. First one is summary. Stress testing is very important because it enhances our router test and evaluation for deployment. This is a more typical deployed network environment. Shankar mentioned the isolated testing where you test only BGP, only OSPF. Well, it doesn't get deployed that way. When a router is deployed in a network, it has many protocols configured at the same time while running traffic and being measured. If that's the way it's being used, that's the way it should be tested. Ensure system and software stability. Under stress, if we can survive, keep CPU utilization at an okay level, make sure we don't have memory leaks, and survive through all this flapping, then we know that this router can go into the network. We also validate we're picking the right next hops with all these convergence events and the nested convergence events. We also verify that the device is in fact manageable under stress. All of this is going on. We can still SSH in and manage the device and have access. Maybe even we can do logging and debug under stress. And then we also find the difficult to detect software bugs. That's more important for the test equipment vendors rather than the service providers. But we make sure we catch those slow memory leaks real early and we can optimize CPU utilization. Okay, so the ultimate benefits, we're ready for deployment. We see higher availability of the routers in the network. Our protocols are more stable, and we can withstand potential DOS attacks that are aimed at resource exhaustion. So given all that, what are our recommendations for everybody? The first one is for the router vendors to actually now use this. So they have they can create deterministic software, repeatable tests and repeatable results from the stress testing so that it is of value to the service providers. From that, the router vendors can assess the interaction of protocols working together and give us now real data that can be used for deployment. Rather than marketing literature that just says, oh, I can do this many OSPF routes or this many BGP routes, We want to know what the scaling numbers are when all this stuff is working together and it's stable. So we can get that now from the router vendors using the stress testing. The test equipment vendors have to put in all of those features, all of them, as I just listed them. And then the service providers can employ this for certification testing, for better deployment. And then they can also use this for characterization of devices so they can plan future deployments of networking devices in the network. You run multiple iterations, you can characterize devices, that gives you better insight into the future and planning of deployments. Okay, and for all BMWG drafts, the last bullet on the slide, we'd really, in the BMWG, appreciate input from the operator environment. The reason we're creating all of these standards for testing is so that when these routers do get deployed, they meet your requirements, your needs. So you actually have, a voice now, a vehicle into how these devices get tested for your needs. So please get involved with the BMWG and post your input on the mailing list. All right? At this point, I think we're ready for questions.
Yes, we have time for a few questions.
On slide number 4, you mentioned a couple
Can you
of...
state your name?
Michael Ville and
Thanks.
Radiance. On slide number 4, there are a couple of drafts mentioned. The second one about methodology doesn't exist in the Internet Drafts Directory, and it is not referenced in the mailing list archive.
Yes, thank you for mentioning that. You'll note it is a 00. We haven't posted that one yet. There is one here that's not listed. There is a framework -00 that did just get posted a couple days ago.
Okay, so that's
Yeah, so there's
intended to be...
thank you for pointing this out for everyone else who's going to be using the slide. Terminology 01 is posted. There's a framework 00 that's posted. The terminology and the framework are being used together to funnel in to create this methodology 00 draft, which will be posted, I guess, in the next 4 weeks or so. Thank you for bringing that up. Any other questions? That's it. It's that everybody's doing this? Who's everybody stress testing? Every service provider is doing the stress testing? No? Okay.
I mean, I just wanted to,
Go ahead.
I just wanted to make an observation as a carrier. One of the things that was expressed as a concern was because there are so many things that are going on in these routers. We've got all these different routing protocols doing different things. There was a concern expressed that these tests may not be repeatable, that the results may be variable. And in fact, that is probably true for most of our routers today. And that is actually concerning, because if you think that we cannot really have repeatable tests with repeatable results, do we really want to deploy boxes that we can't do it? I mean, that we can't run such tests on. So it's something that, I encourage you to, get involved in and, help us define that better, and maybe get our vendors also, on the bandwagon.
Go ahead.
Thank you. Tony Capella, Server Central. One thing I was going to ask you, when you were mentioning that you will set up test scenarios with some 2,000, I believe it was the figure of flows of active traffic through the device, what packages or software tools are you using to create flow-level traffic patterns?
For the purpose of that particular specification, we haven't really defined which device you might use. This is just a framework document, so we don't necessarily prescribe that you use this vendor or that vendor. It's more of a framework where you can substitute whatever numbers are most accurate to reflect your environment.
Understood. Thank you.
And I would like to add that the 2,000 was just an example. Okay, in the framework document, we actually don't specify the exact value, but for the purposes here, we gave an example value.
Sure. If I could mention also regarding the flow issue, or the number you mentioned, when you're doing the stress testing, it seems as 2,000 might just be an average baseline. What would you consider stressful?
10,000.
Why not 120 or more?
Sure,
Okay.
you could do that, absolutely.
Okay, thank you.
You didn't mention this underwriter laboratory thing, which has that sort of product testing as an independent company. Are you advocating just trying to do all this stuff within the IETF or on a volunteer basis, or do you think that we really need some third-party thing that's incorporated to do this, and it's tied into the insurance industry and due process when things go wrong? I mean, what is your...
Well, I like the idea because, geez, maybe it could make us money. But thank you, Kevin. So we are doing this on our free time in the IETF, as everybody else who contributes in the IETF is doing. Right now, we don't know of a third-party lab that's doing any of the stress testing. But we're hoping once this does become RFC, that will motivate one of the many third-party labs to actually go out there and make this part of their product line. We actually haven't then gone to any of them. I don't know how that ties into the IETF process. I don't think there is any vehicle to go direct from IETF to a place like Underwriters Lab. But maybe that's something we can. Yeah. Okay. All right. That's it. Well, thank you very much, everyone.
Thank you, guys.